Hello friends, welcome back. In this tutorial, we will study about breadth first search algorithm. Breadth first search is an algorithm for searching a graph, right? In this algorithm, we start searching the graph from a particular vertex called source vertex, and it is usually denoted by S, right? This algorithm discovers all the vertices which are at distance k from source vertex before discovering any vertex which is at distance k plus 1 from the source vertex. So the search proceeds in breadth first manner, right? In breadth first search, the search proceeds in breadth first manner, right? In breadth first search, for each vertex v of graph, we maintain three variables, right? In breadth first search algorithm, for each vertex v of graph, we maintain three variables. First is dv, right? Second is color v, and third is pi v, right? dv stores the distance of vertex v from source vertex, right? Here, distance means smallest number of edges from source vertex to vertex v, right? Variable color v stores the color of vertex v. In breadth first search algorithm, right? Color of each vertex can be white, gray, or black. If the color of a vertex is white, then it means this vertex has not been discovered. Right? Initially, all vertices of the graph are white. When a vertex is encountered first time, its color is changed from white to gray. Right? When a vertex is completely processed, its color is changed from gray to black. Right? Variable pi v stores the predecessor of vertex v, right? Now let us see how the breadth first search algorithm works on graph G. First of all, we will color all vertices white except source vertex S, right? So for all vertices v of graph G except source vertex S, value of variables color v will be white, right? Distance of all vertices from source vertex except source vertex S will be set to infinity. So for all vertices v of graph G except source vertex S, value of variable dv will be set to infinity. Predecessor of all vertices will be set to nil, right? So for all vertices v of graph G, including source vertex S also, value of variable pi v will be nil, right? Now, color of source vertex S is set to gray, and its distance from source vertex S is set to 0. So color of source vertex S will be gray, right? So the value of variable color S will be gray, and since the distance of source vertex S from source vertex S is set to 0, therefore the value of variable ds will also be 0. Now we will use a Q, right? So first of all, we will enqueue source vertex S in this first in first out Q, right? Now, until this Q becomes empty, we will repeat this procedure. First, we will dequeue a vertex from QQ. Let this vertex is U, right? Then for all white vertices V which are adjacent to vertex U, we will set their color gray and their distance from source vertex S is set to 1 more than the distance of vertex U from source vertex S, right? And vertex U will become their predecessor, and then we will enqueue all of them in QQ, right? At last, we will change the color of vertex U from gray to black. Now, let us see how the breadth-first search algorithm works on this graph, right? Here the vertex S is the source vertex, right? So what we have to do, we have to see how this breadth-first search algorithm works on this graph, right? So first of all, what will we do? For all vertices except the source vertex S, we will set their distance from the source vertex as infinity, right? So the distance of all vertices from the source vertex S is infinity except the source vertex, right? Distance of source vertex S from the source vertex S is set to 0, right? And the predecessor of all vertices of this graph is set to nil, right? And color of all vertices of this graph except the source vertex is white, right? And the color of source vertex is gray, right? Now what will we do? First of all, we will enqueue this source vertex S into QQ, right? So here we have enqueued this source vertex S in QQ, right? Now after this, what will we do? We will repeat a procedure until this Q becomes empty, right? We will dequeue a vertex from this QQ, right? And then for all white vertices V which are adjacent to that vertex, we will set their color gray and their distance from the source vertex S is set to 1 more than the distance of a dequeued vertex from source vertex S, right? And the dequeued vertex will become their predecessor, right? And then we will enqueue all of them in QQ, right? At last, we will change the color of dequeued vertex from gray to black, right? So what will we do? First of all, we will dequeue vertex S from QQ, right? So we have dequeued the vertex S from QQ, right? Now you can see that there are only 2 white vertices which are adjacent to vertex S, right? There are only 2 vertices R and W which are white in color and adjacent to vertex S, right? So now the distance of vertices W and R from source vertex S will be set to the distance of vertex S from source vertex plus 1. The distance of a source vertex S from source vertex S is 0. So the distance of vertices W and R from source vertex S will be set to 0 plus 1, that is 1, right? Now, the color of these vertices R and W will be changed from white to gray, right? And then vertex S, right, will be set as the predecessor of vertices R and W, right? So pi W is equal to S and pi R is equal to S, right? It means the predecessor of vertices R and W is S, right? Now, after this, we will enqueue these two vertices R and W in QQ, right? So here we have enqueued these two vertices R and W in QQ. And after this, color of source vertex S will be set to black, right? Now, the QQ is not empty, right? So we have to repeat this procedure again, right? We will dequeue a vertex from this QQ, right? So here we have dequeued the vertex R from QQ, right? Now the vertices, white vertices adjacent to vertex R is vertex V. Now there is only one vertex, that is vertex V, which is white in color and adjacent to vertex R, right? So there is only one white vertex which is adjacent to vertex R, and that is vertex V, right? So what will we do? First of all, we will change the color of vertex V from white to gray, right? And the distance of vertex V from source vertex S will be set to distance of vertex R from source vertex plus 1, right? So distance of vertex V from source vertex S will be set to 1 more than the distance of vertex R from source vertex S. Distance of vertex R from source vertex is 1. So distance of vertex V from source vertex S will be set to 2. So dV will be set to 2, right? Now after this, we will enqueue this vertex V in QQ, right? And before enqueuing this vertex V in QQ, we will set the vertex R as the predecessor of vertex V, right? So here vertex R is the predecessor of vertex V. So the value of variable pi V will be equal to R, because R is set as the predecessor of vertex V, right? And at last, what will we do? We will change the color of vertex R from gray to black, right? Now the vertex R has been processed because its color has been changed to black, right? Now the queue is not empty, so we will repeat this procedure again. We will dequeue a vertex from this queue. So we will dequeue the vertex W from this QQ, right? Now see this vertex W, right? Now first of all, we will see how many vertices are adjacent to it and their color is white, right? So there are 2 white vertices which are adjacent to vertex W, right? And these vertices are vertex T and X, right? These are 2 white vertices which are adjacent to vertex W. So first of all, we will change their color from white to gray, right? And we will set their distance from source vertex as 1 more than the distance of vertex W from source vertex S. The distance of vertex W from source vertex S is 1. So the distance of these 2 vertices T and X from source vertex S will be equal to 1 plus 1, that is 2. So the value of variable dt and dx will be equal to 2. Right? And then we will set the vertex w as the predecessor of vertices t and x. So the value of variable pi t and pi x will be equal to w, because w is the predecessor of these two vertices t and x, right? Now we will enqueue these two vertices t and x in q, right? So here we have enqueued these two vertices t and x in this q, right? After this, we will change the color of vertex w from gray to black, right? So vertex w has been processed, right? Now we will dequeue a vertex from this q. So we will dequeue a vertex v from this q, right? Now the vertex v does not have any white adjacent vertex, right? So we will change the color of this vertex v from gray to black, right? This vertex v does not have any white adjacent vertex, right? So we have nothing to do with the vertices which are white in color and adjacent to this vertex v. So we have directly changed the color of this vertex v from gray to black, right? So this vertex v has been processed, right? Now we will dequeue the next vertex from q, right? So we will dequeue the vertex t from this q. So here we have dequeued this vertex t from q, right? Now see, this vertex t has only one white adjacent vertex, that is vertex u. So we will change the color of vertex u from white to gray, right? And the distance of vertex u from source vertex s will be set to 1 more than the distance of vertex t from source vertex s. Distance of vertex t from source vertex s is 2. Therefore, the distance of vertex u from source vertex s will be set to 3. So the value of variable du will be set to 3, right? The value of variable du has been set to 3, right? Now we will set the vertex t as the predecessor of vertex u, right? Vertex t has become the predecessor of vertex u. So the value of variable pi u will become equal to t, right? Now we will enqueue this vertex u in q, right? And after this we will change the color of vertex t from gray to black, right? So this vertex t has been processed. Now we will dequeue a vertex from q. So we will dequeue the vertex x, right, from q. So here we have dequeued the vertex x from q, right? Now there is only one vertex which is white in color and adjacent to vertex x, right? And that is vertex y, right? So here there is only one white vertex which is adjacent to vertex x, and that is vertex y, right? So first of all we will change the color of vertex y from white to gray, right? Now we will set the distance of this vertex y from source vertex as 1 more than the distance of vertex x from source vertex s, right? Distance of vertex x from source vertex s is 2, right? So the distance of vertex y from source vertex s will be set to 3. So the value of variable dy will become equal to 3, right? After this we will set vertex x as the predecessor of vertex y. So the value of variable pi y will become equal to x, because now the vertex x is the predecessor of vertex y. Now we will enqueue this vertex y in QQ, right? We will enqueue this vertex y in QQ, right? And after this we will change the color of vertex x from gray to black. It means the vertex x has been processed, right? Now we will dequeue a vertex from QQ, right? So we will dequeue the vertex u from QQ, right? Now the vertex u does not have any white adjacent vertex, right? So there is no white vertex which is adjacent to vertex u. So we will change the color of vertex u from gray to black. So vertex u has been processed. Now we will dequeue a vertex from QQ. So we will dequeue the vertex y from QQ, right? Now there is no white vertex which is adjacent to vertex y. So we will change the color of vertex y from gray to black, right? Now vertex y has been processed. Now the QQ has become empty. Now there is no vertex in this QQ. So we will stop there, right? So here in this way we have traversed this graph by breadth first search algorithm, right? In breadth first search algorithm, vertices are traversed in breadth first manner, right?